Hey guys, so we're gonna continue a series with such kind of chapters. It's gonna be logarithm first, then it's gonna be trigo phase 1, then the quadratic equation, then sequence and series, then trigo phase 2. And in trigo phase 2, we have to deal actually with the trigonometric equations. Okay. Now, before talking about it, we must revise some basics from the past that we already discussed. It's going to be the quadratic equation. So it is quadratic equation. Now, why it is pretty important for me to discuss about it? Because in logs, when we will find out the ranges, domains, and all that, it's going to be pretty important for us to realize what actually does quadratic looks like. Okay. So before we're going to talk about it, we know that the general equation of a quadratic looks like this. It's ax squared plus bx plus c. Now this is a quadratic polynomial, but if I'm going to set it equal to 0, then it becomes a quadratic equation. Okay. Now in case of a quadratic polynomial, we can have three types of cases. We have actually three cases. The first case will be when the parabola is going to not cut or touch the x-axis. So it may look like this. It can be a downward parabola, it can be upward parabola, depending upon the coefficient of x squared. But we're not too much focused about it here, but we're just focused about this, that if the parabola does not cut or touch the x-axis, in that case the discriminant b squared minus 4ac is going to be lesser than 0, or it will be negative number. Okay. Now in such kind of cases, I might give a good example. For example, if we look at a graph of this, maybe this is a graph. It's a graph of x squared plus 1. It's a sketch graph. For example, I have x squared plus 1. So I have this function. Now in this kind of function, the parabola does not even touch or cut the x-axis. So in this kind of parabola, there's not going to be any x value which will make the whole quadratic equation, or which will make the left side equal to right side, or which will make the left side equal to 0 as well. So there won't be any x values for such kind of parabolas. Okay. Now we have to talk about the second case here. In that case, we might have a parabola, or we might deal with a parabola where the parabola touches the x-axis. Okay. It can be upward again or a downward. It may look like this, or it may look like that. So we can have upward or we can have a downward parabola. Again, in this case, the discriminant b squared minus 4ac is mathematically going to be equal to 0. Okay. Now, what is the best example for this kind of parabola? Well, a perfect square. For example, we have, let's suppose we have a function f of x equals x minus 1 whole square. I can make any parabola of this kind, because when I'm going to open it up, I'm going to get three terms. I'm going to get x squared, I'm going to get minus 2x, and I'm going to get 1 as well. But that will be a quadratic equation. And if I'm going to draw that kind of graph, it's going to touch the x-axis. It's not going to cut, it's going to touch the x-axis. So you can make it on your own. You can make any one like this. Suppose we have, but you have to keep it inside a square. That's it. So actually this kind of parabola. So perfect square of a binomial, you can say, is always going to be a parabola that's going to touch the x-axis. Okay. It can be anything. You can make it 3x minus 2, maybe. Okay. So it can be like this. So we're going to talk about this kind of parabola. We already talked about it. Okay, now we're going to move to the next type of thing. That is the parabola when the parabola does not, when the parabola cuts the x-axis at 2 points. Again, it can be upward parabola or it can be a downward parabola. In both cases, upward parabola, downward parabola. Okay, now in this case, the discriminant b squared minus 4ac is mathematically greater than 0. So if we have discriminant greater than 0, we're always going to have a polynomial, a quadratic polynomial that's going to cut the x-axis at 2 points. So what will be a good example for this kind of parabola? Well, let's see, x squared minus 5x plus 6. Well, this is the best example in my opinion. It has actually roots at 2. It has 2 roots. It cuts the x-axis at 2 and 3, I think. Okay, so these are the three things that can happen with the parabolas. Okay, now let's move to the next thing that we might have already discussed in 9th or 8th classes, but that is pretty important for us to memorize or just to give it a reminder, that is the formulas, some basic formulas and pretty important formulas. So formulas. So the first among them will be x minus y multiplied by x plus y. So this formula is going to be equal to x squared minus y squared. So this is the first formula that I have to deal with. So the second one, also important in my opinion, x cubed plus y cubed is equal to x plus y multiplied by x squared minus xy plus y squared. And one more along with it is x cubed minus y cubed. That's mathematically equal to x plus y, sorry, it's x minus y here, and x squared plus xy plus y squared. So these are the three important formulas, and along with them is one more that is really important in my opinion, that is this one, the bigger one. I'm talking about this whole x cubed plus y cubed plus z cubed minus 3xyz is mathematically equal to x plus y plus z sigma x squared minus sigma x multiplied by y. Now this formula is pretty important. Now what might be important, this sigma x squared, if you are not too much familiar about it, it actually means x squared plus y squared plus z squared minus sigma xy minus yz minus zx. Actually we have 6 terms here, okay? Now we might be asked, how can left side be equal to 0? Now left side can only be 0 when either one of the two brackets is 0. Either if this bracket is 0 or mathematically this bracket is going to be 0. Now if this bracket has to be 0, that means x plus y plus z has to add up 0. Okay, so that's the only possibility for this bracket being 0. Now if second bracket has to be 0, it becomes a bit complicated here. Now if second bracket has to be 0, that means we have 6 terms. I'm going to open it up where x squared plus y squared plus z squared. Sigma x squared represents these 3 terms. Then we have minus xy minus yz minus zx. This has to become 0. Okay. Now what I'm going to do here, I'm going to multiply both sides by 2. Why I'm doing that? Because it will let us know why I'm doing that. This becomes 2x squared plus, I'm multiplying every term by 2, plus 2z squared minus 2xy minus 2yz minus 2zx equals to 0. Now here this actually can be written in a compact form like this: x minus y whole squared plus y minus z whole squared plus z minus x whole squared equals to 0. Now think about it. If I'm going to open all the 3 terms up by the formula x minus y whole squared, I will get this thing back. You should not worry too much about it. If I'm going to open it up, I will get this thing back. Okay. Now why I wrote it in this form? Because I realized that I have squared, sum of square of 3 terms. So that means the only number on the left side that I can get is going to be 0 or greater than that, because square of any number is always going to be positive. So this will always give me a number greater or equal to 0. This bracket will always give me a number greater or equal to 0. Again, this bracket will give me a number greater or equal to 0. Now, not only that, I should get an answer 0. That means the only possibility for all the 3 brackets is to be 0. That means they have to be 0 simultaneously at the same time. So that can only happen when x will be equal to y, and then x and y cancel out, and y will be equal to z and z will be equal to x. So that means the calculation will be x will be equal to y will be equal to z. Now if the left side, or if this bracket has to be 0, that simply means x has to be equal to y, which has to be equal to z. Now you might be wondering, or if you're clever enough, might say, wait a minute, can they be 0 simultaneously? Can both the brackets, this bracket and this bracket, be 0 simultaneously? I might say yes, because if, think about it, if all the terms become 0, if x becomes 0, y becomes 0, z becomes 0, then this bracket becomes 0, and at the same time, this bracket becomes 0. So simultaneously, there's a possibility of both the brackets becoming 0 is when all x, y, z become 0.